Section 8.1 has really no page. It is in your book, but the numbers that I have are totally different. So that's why I uploaded my copy, because I don't have a PDF from the PCC Custom Edition book. So just use this homework. It's already in files, along with 9.1 and 10.1. So I need to remind you really quick, back in Math 3, do you recall Pascal's triangle? One plus 1 is a 2, 1 plus 2 is a 3, and 2 plus 1 is a 3. If you recall, this is like a plus b to the 0 power. This is a plus b to the 1 power. This is a plus b squared. And this is a plus b. We don't need to go above cube. So if I am, and again, this section is review of a lot of things except for the last 5 problems. I'm leaving that all by itself. I need you to go over your multiplication, your factoring, your combining like terms techniques. So if you could jump here and say this is x squared plus 8x plus 15, that would be fine. You really don't have to show much work. If I go for a minus b squared, and if you recall how this works, this is very useful. It's a 1 to 1. So that is an x squared, an x, and a 5 squared. Right? I misspoke. If you recall the binomial theorem, so you're going to start with an x squared, then x to the 1 times negative 5 to the 1, then negative 5 squared. Of course, you don't need to do this. I'm just reminding you of how the binomial theorem works. You should know also that a plus b squared is a squared plus 2ab plus b squared. And if it's a minus, you put a minus there. But here I'm just illustrating how you use that. And what you're going to do, you're going to say this is the second. So you're going to multiply this by 1, this by 2, and this by 1. And this is x squared minus 10x plus 25. Here, cube, well, it's going to be x cubed 1 to the 0, x squared 1 to the 1, x 1 squared, and 1 cubed, and kind of like x to the 0. And here you're looking for the cube 1331. Or just like when I was in high school ages ago, we memorized that a plus b cubed was a cubed plus 3a squared b plus 3ab squared plus b cubed. Whatever works. So this is x cubed plus 3x squared plus 3x plus 1. And here I could just jump at it straight. So, that's the first one cubed. That's 27x cubed minus 3 times a squared times b plus 3 times a times b squared plus a negative 2 cubed. That is 27x cubed minus 654x squared plus, this is a 4 times 9, 36x minus 8. Okay, a quick reminder on dividing. You need to know both long division and syntactic division. Long division, again, five x to the 4th divided by x squared is 5x squared. Multiply. Subtract. Bring those down. 11x squared divided by x squared is a negative 11. Subtract. So normally it's sufficient for you to write There's the ratio. And you would write the remainder as negative x plus 10 over x squared plus 2. That's sufficient. On the next problem, I am going to take this and write it two different ways. Let's see, maybe I'll move this back. Yeah, I don't think I needed that. Yeah, no, it's okay. So one way of doing this is using long division. That will be 3x squared, 3x squared, plus 6x, 3x cubed. Okay, I don't know why I'm rushing. Subtract, change both signs. Minus 7x, negative 7x squared, minus 14x, subtract. Plus 15, 15x plus 30, and if you subtract. Another way of doing this, but there's a catch. You can only use syntactic division if the divisor is linear. 3, the square, the linear and the constant, and set this equal to 0. And the way it works, you drop the first number, multiply, add, multiply, add, multiply, add. If this is a polynomial, this is always 1 degree less, and you move in order, and the remainder is right there. And you notice this answer and this answer are the same, and the remainder is identical. So syntactic division is a lot more efficient. And now in factoring, if you remember how this works, to factor, two steps. Step number 1, you count the number of step number 1, you look for greatest common factor. Step number 2, you count the number of terms. If you have 2 terms, 2 squares with a minus, 2 cubes with a minus or a plus. 3 terms, you would use any method you learned. There are 4 techniques of factoring, and 4 terms use grouping. And if I look at the first 78, so again, I'm not sure how much of this review you need. This is the difference of squares. You would think, can I write this as 2 squares, 3 and an x, and you copyright that. You write it twice, 1 time minus, 1 time plus. And there it is, you just factored it. Factoring is transforming the problem from addition and subtraction to multiplication. And here, factor completely. So greatest common factor is a 3. Again, 2 steps in factoring. A 1 minus 9x squared. And can you write those as squares? Because that's a square. 3x. Okay, why so small? And a 1. So you write it without the squares. Again, that formula right there. 1 and 3x. 1 and 3x, 1 time minus, 1 time plus, and don't forget to copy the 3. And I just transformed the addition and subtraction into multiplication. 2 cubes, well, 1 is unique. You could write 1 to any power, and the cubes with a minus turns out to be this formula. You would write them without the cubes, the 5x plus 1 and the minus 1. You would square the first, square the last, and multiply those two. This is a positive, and this is always the opposite of that. And if you work this out, this is 5x, and this is 25x squared plus 10x plus 1, plus 5x plus 1 plus 1. This turns out to be 5x times 25x squared plus 15x plus 3. And the three terms, I look for a greatest common factor. I noticed 3y is common in all of those. That will be a y squared minus 6y minus 16, I think. 3, yep, 3. And factors of 16 that subtract to give you a 6, 8, and 2. And you want a negative 6, so you want negative 8 and a positive 2. And there's the homework. Number 45, 55 through 59, every other odd. 77 through 129, you could do the odds, you could do every other odd, or you could do every other. You could pick and choose if you like, as much as needed. But by that, you're telling me you know how to factor properly, and I'm going to assume that you could factor anything after that.